NASA's Mars Exploration Rover mission, or Mars Rover for short, is an ongoing robotic space mission involving two rovers, Spirit and Opportunity, exploring the planet Mars. In our presentation, we are going to discuss three main contributions of engineering in the Mars Rover project. To do so, we are specifically going to talk about the contribution of software/computer engineering, mechanical engineering, and chemical engineering. We are also going to talk about different impact of the Mars Rovers project on today's society. Mechanical engineering in the Mars Rover. Mechanical engineering is used in many aspects of the design and features of the Mars rovers. Mechanical engineers must design the rover to meet certain conditions, such as the weight, ability to withstand space-like conditions, and design of an efficient landing process. Mechanical engineering provides the devices and systems necessary to operate the rovers. Without it, processes such as the landing and the successful mobility of the rovers will be impossible. The landing sequence for the Curiosity rover is often called the 7 Minutes of Terror. Because of Mars' thin atmosphere, it took a major engineering feat in order to slow the rover down enough to land it. Engineers had 7 minutes from the top of the Mars atmosphere to the surface. Engineers developed an intricate system of maneuvers including 76 different pyrotechnic devices, a supersonic parachute that had to withstand 275,000 newtons of force, and a rocket-powered device called a skycrane. The rocker boogie system is the suspension design used for all of the Mars rovers since Pathfinder. The system utilizes a 6-wheel drive platform without axles or springs. The design allows the rover to climb over large obstacles easily. Using this mechanism, Curiosity can drive up slopes of up to 45 degrees. This design is a major mechanical engineering feat, and without it, the Mars rover would not be able to navigate Mars like they do now. Software and computer engineering in the Mars rover. Software engineering provides the computing and commands necessary to operate the spacecraft and its subsystems. Why and how was a computer system embedded in the Mars rover? It must withstand the high radiation levels and large temperature changes in space. For this reason, their computational resources are limited compared to systems commonly used on Earth. How does it work? A rover uses autonomy software to make decisions based on observations from its sensors. Each pair of images could generate 20 navigation 3D points with the initial software version the craft landed with. The MER rover can generate 15,000 to 40,000 3D points. Like all spacecrafts, the Mars Science Laboratory rover has a central computer that constantly monitors the health of the spacecraft, checks to make sure commands are being executed, and handles communication to and from Earth, as well as to other spacecrafts orbiting Mars. Each day, software and computer engineers on Earth send a sequence of computer instructions for the day's activities. Engineers will also periodically send software upgrades to keep the rovers updated with the most current technology. All software sequences are tested on Earth using surrogate rovers under similar conditions before being used on Mars. Chemical engineering in the Mars rover. Along with the mechanical and computer components of it, the chemical engineering aspects of the rover also contributes to its performance and has a great impact on society. The mysteries of the galaxy are indeed so profound that people have been wondering about extraterrestrials' life in outer space since the development of science. Here, the chemical engineers are key to gratify people's curiosity. In 1976, NASA's Viking landers carried out the most famous chemistry experiments done on Mars. They extracted a sample of soil on Mars and added a solution of amino acids and other nutrient molecules that were radio-labeled with radiocarbon 14C. After a few hours, the sample gave off CO2 that was also radio-labeled with radiocarbon 14C, an indication that the molecules from Earth were being broken down by something in the soil, a possible indication of life on Mars. Although the experiments of the possible life in outer space as long, did not last as adding more organic molecules, a week later failed in producing more CO2. The Viking mission provided indisputable evidence that liquid water once flowed on Mars, as minerals like silicates, which can only be formed by crystallizing out of a liquid medium, were detected in the process of the experiment. Likewise, chemistry on Mars is a ceaseless sequence of discovery and surprise. As a result of the evidence that Mars once had flowing water, two Mars exploration rovers named Spirit and Opportunity were built for the purpose of following the water. Here, the responsibility of chemical engineers, along with the engineers in other disciplines, were to build an instrument that could probe the elemental composition of Martian rocks to see whether they were formed in or altered by water. Spirit and Opportunity landed on Mars in 2004, and Opportunity is still sending back data from the Miradani Planium, a vast plain near the Martian equator. Data gained from Opportunity and Curiosity has contributed in finding hints of water, much more neutral than those normally found on Mars. If this discovery is true, this may be an indication that Mars wasn't as harsh and inhospitable as it is now. Based on that of Curiosity, NASA is now designing the Mars 2020 rover, in which its main focus is collecting samples of rock and soil and hermetically sealing them and bringing it back to Mars. Their chemical components will help characterize the geology and habitability of the Mars environment and eventually lead to human exploration. Impact on the society of the Mars rover. The technology developed by mechanical engineers for the rover have had a huge impact on the society today. Many technologies developed for the Mars rover will be used in future space explorations. NASA says the techniques used to land the Curiosity rover will help to land other larger payloads in the future. This could pave the way for successful implementation of human outposts on Mars. The new technology developed for Curiosity allowed it to drive further, climb steeper slopes, and provide access to areas that otherwise would be inaccessible.